Okay, so this is the first session. In this session, I'm going to talk about the basics of Python as a programming language, Revit Python shell, which is a tool that we use in Revit to basically as a command prompt for Python. The Revit Python wrapper, which is a library written in Python for Autodesk Revit, and the pyRevit itself. Based in this course, in this whole series, my assumption is going to be that you know the Python language. There are plenty of tutorials for this language, and there are a lot of courses and stuff like that, so it really doesn't make sense for me to start teaching you Python. I would expect you to understand the language, the basics of the language, and the only stuff that we're going to talk about really Python-wise is our differences between Python and Iron Python. And when I get to talking about Python, I'll expand more on that, so you know what is the difference between Python and Iron Python. So let's talk about Python, which is going to be the first thing that we're going to talk about today. If you go to the Python website, there are plenty of resources on this programming language as far as learning it. You can download the code, download the basically the programming environment for two different versions of Python that is available. I would highly suggest sticking to the 2.7 series because that's where the Iron Python engine that we use under Revit is also. There are some differences, minor differences between these two, but if you stick to the 2.7, at least the similarities are going to be a lot more. The most important piece that I want to show you right now is the documentation. If you go under documentation tab and click on the Python 2 documents, this is the page. This is really the page that I started learning Python from. I started doing the tutorials, going through the list and learning how the program works and the program flow and how to import modules and how to do mathematics and stuff like that in it. And by the time that I got to the sort of like the end of this, towards the end of this, I had a really good solid understanding of how Python works. It's a very simple language and it's easy to pick up. There is one piece of information, one chapter in this that's really important. It's called a language reference. What I want to point to you about this is that you kind of have to understand that Python language is a standard. This committee that develops the Python language designs this language in a format that basically they describe how Python language should work. So, for example, if I want to go under one of these chapters, let's go under one that talks about the yield command, for example, the yield statement. So it goes into yield statement and it's got a standard expression on how to basically explain how a programming expression works. And it explains how this how this yield statement is supposed to function. Programmers will read this and will go implement a interpreter that will understand a text file based on the descriptions that are provided here. So the implementation would look at the text file, which is your Python script, and whenever it gets to the yield statement, it would basically provide these actions as it's described in this document. So once again, the Python standard tells the programmers that develop the Python implementations that I'll talk to you about a little bit more. It basically tells them how this programming language is supposed to function. Now, if you go under the alternate implementations, which is going to be the first link here, you can see that the CPython, there are a couple of different flavors of Python are listed here. CPython is the original and the most maintained implementation of Python, written in C. So C is another programming language. Somebody or this group of programmers sat down and wrote an interpreter in C that would interpret the script files as Python, and it would basically do whatever the program is telling it to do. There are a couple of different ones, for example, like Jython is Python implemented in Java. So instead of being implemented in C, it is implemented in Java. What's nice about this is that because it's implemented in Java, it can talk to the other Java applications and libraries and stuff like that. There are two Python for .NET. I think this one is the first one is not maintained anymore as far as I can remember. But anyways, IronPython is one of the most well-known implementations of Python that is basically for .NET platform. And .NET platform is the platform that Microsoft has created for its own operating system and as applications, and that's the platform that Autodesk Revit is also using to basically do its job. And that's why we really need the IronPython implementation, because we want this implementation to be able to connect to the .NET platform, to connect to Revit, and be able to perform tasks and query information and stuff like that. The tutorials that you see on this website are related to the Python language. They're not related to the C Python per se. You might see stuff in here that talks about some of the modules and stuff like that that are only available in the C Python implementation, but all the core libraries and basic features of this language is available in both versions. There are going to be some maybe minor changes, like for example, if you go and find some other libraries for C Python that other people have developed, they might not work in IronPython because of minor differences in behavior. And I'll make sure that I'll point those out to you. But for the most part, if you follow this tutorial on this website or any other tutorial that talks about the Python 2 series, basically, you should be able to write programs in Python for Revit without any problem. The other component that we really need to learn is the Revit API, which I'm going to get to in the next session. So this is as far as Python goes. You do not need to technically install IronPython on your machine to do this. Revit gets shipped. Well, the new versions of Revit come with Dynamo pre-installed, and they get shipped with the IronPython engine inside them. You can use Python language as macros in Revit, but what we want to do is we want to get to this. We want to be able to have tools and buttons that are available in user interface, very simple, very easy to access to us, that instead of being compiled on C#, they are actually written in Python, which is much easier to develop, much easier to understand. They're a lot slower than C#, I give you that, but it's great for a person that is an engineer, is an architect, have basic understanding of a language like Python, because it's simple and it's easy to learn, and they can develop simple tools to query information, to make changes to the model, and basically interact with the model in a different, more productive way. Okay, so this is as far as Python goes. The second thing I want to talk to you about is a Revit Python shell. Let me search for Revit Python shell. Oh, I missed the Revit. Okay, so this guy, Darren, is the person that is in developer for this add-on. Revit Python shell is an add-on for Revit. You can go under its GitHub repository and go under releases, and then download the most recent version of the executive installer and install it for the Revit version that you have. The 2017 obviously is the most recent version that's been compiled. I know that Revit 2018 is out, and I know that he's working on compiling a new installer for the 2018. But anyways, when you download this and install it, you'll have a button under the add-in sections in Revit, which is the interactive Python shell, this is basically a Revit Python shell, or we call it RPS. Run it, and basically it opens this window for you, and it is a standard Python console. If you have worked with Python, this is familiar to you. Generally, whenever you run Python, in basically prompt mode, in console mode, you would get this information about the engine or the version of Python that's running. Notice that it says IronPython, because again, we're using IronPython to communicate with .NET platform, and it basically tells you that's on .NET that version, and we're using that to communicate with Revit. So this is a very nice, very nice, super helpful tool. So here you can type in commands, Python commands, or and statements. Like for example, I can create a variable called test, and I can assign 0 to it, and then later I can check the value. Or you can use this pad that's under the window to write longer application. Let's say I want to do this, and you can click on play, and it would execute that piece of Python script for you. So we're going to use this a lot to basically inspect into our selections and test a few ideas before we actually implement them in our scripts and stuff like that. Whatever I'm going to show you here is my personal preferences, so feel free to work in a way that you like. But I like to use RPS a lot for inspecting objects, making sure what I'm planning to do works actually before I actually put it in the script and start playing with it. This is basically sort of like I use it as a sketchpad for ideas, and also it's really helpful for quick changes. I have also a series of snippets that are like little pieces of script that rename a bunch of views for me or things like that I don't really want to create tools for because they're super custom. So I just drop it here. I just copy and paste it, drop it here, hit play, select the objects that I want and stuff like that, and I apply those changes to those objects. So make sure you have this tool installed and ready to go. There's a very nice feature to Revit Python shell, which is if you go under configure and under init script and startup script, you can assign two scripts that basically RPS or Revit Python shell runs every time it is starting. So every time this second script, every time Revit is starting up, RPS runs the script. And this init script is basically a script that gets executed every time you open this interactive Python shell. So if you want to do like standard imports and stuff like that, just to be ready when you get to the prompt, everything is ready for you. You can put all those in a script and basically just assign it to in the configurations. And I'll show you how mine is set up, and I'll also share a link for it here. Anyways, this is as far as Revit Python shell goes. Make sure you have it installed and ready to use. The other piece that we really want to talk about is pyRevit itself. So far, you know how you can write a Python program for Revit under Revit Python shell. But the problem with this is that you kind of have to save the script somewhere else and then open it from here every time and run it. And it's more tedious. It's a couple of steps and stuff like that. And especially if you want to distribute it to other people, it's going to be hard for them to find the scripts and know exactly what's going on. And that's why I really sat down and developed pyRevit to basically go through a list of Python scripts that have been pre-written and understand those and create button for those in this sort of like a nice user interface. So they're really easy to use and easy to find and much more understandable, and it's got like tooltips to them and stuff like that. But basically every time you click on this button, what pyRevit does is exactly the same as every time you click on the play button in RPS. So it basically creates an IronPython engine and runs that script that you have written inside, connects it basically to Revit and runs it inside Revit environment. That's exactly what happens every time you click on one of these tools. And if you hold Alt and click on one of these tools, let me show you a simple one. Hold Alt and click on a tool. See, it takes you to a script. This is a Python script that is the script behind that tool. Now, I am using some of the features that I have personally developed over time. Like for example, this script utils module and Revit utils module are only available if you're using pyRevit. So you can't really copy all this script and then come back and paste it here and expect it to work. Sometimes it works, sometimes it doesn't. And that's why you kind of have to work in an environment like this to be able to use the different code pieces that you use often and share it between different tools and stuff like that. And we'll get to the details of this later. I just wanted to give you a sort of like a bird eye view of how things work in pyRevit. So basically, every one of these tools has a script assigned to it, associated with it, basically, that is the core of that tool and does its job. The beauty of this is that while I have this Revit session open, I can go open one of these scripts, make some changes to it, and then come back here and run this tool, and it would run the newest version of the tool, because this button really remembers the address of this file, and every time we click on it, it runs this file. So this is the major difference between this and using a language, a compiled language, or like C# for this. In C#, if, for example, if any of these add-ins want to make changes to them, they have to go to the source, recompile it, close Revit, load it again, and then test it. And it's great for software programmers and add-in developers because they have access to basically a tool and a programming language that runs a lot faster and is more efficient and stuff like that inside Revit. But for us architects and engineers and other people that really we're doing something else that's in our job, this is super helpful because we don't really need to focus on the tool development as much. We don't need to learn too much about computer programming and the differences between compiled and interpreted languages and stuff like that. This is basically for us a sketchpad that we can create simple or more complex tools and do stuff with them. Software programmers and professional developers use languages like this for prototyping. So they can write a script here in Python, make sure that the idea that they have for that tool works, and then later they can take this and go to C# and actually sit down and develop it properly, that is efficient and everything else, and they can it's ready to to be sold outside and supported and stuff like that. So Python and C# are really not competitors to each other. They're used and designed for different purposes. What I care about the most about Python is that I can do my job and I can open this and I can write a quick script and query the information that I need or make the little change that I need right then and there without needing to know or dive too deep into computer programming. With that said, the last piece that I want to talk about is Revit Python wrapper. So if you have the most recent version of pyRevit, I provided these two links over here as well, which is to the Revit Python wrapper repository and its documentation. Revit Python wrapper is a library developed by Guy Talarico, and I'll show you his information here. If you go to the repository, he is the owner and maintainer of this project. And if you click on his name, this is his profile. So he has created this Python module that makes it, the goal of this is to provide a more Pythonic interface to Revit's API. This will make it much simpler for us Python programmers to be able to talk to Revit. The reason for this is that Revit's API has been written in C#. And in order for us to be able to communicate to this program, even through the other Python language, you still need to dive deep into the documentation of these of Revit's API, which is all in C#, and it might be more complex than what expected to a lot of people. So the goal of the Revit Python wrapper is really to provide a much more Pythonic and simpler interface to the functionalities in Revit's API. Now, with that said, the goal is not to provide and basically mirror all the functionality that is in Revit API, because that's just going to be insane and there's so much stuff in there. But at least it makes the API access much more approachable, and it matches the format of basically the syntax of the Python language and the way you get used to do things in Python. As of pyRevit version 4.4, Revit Python wrapper is a standard part of pyRevit. This is a separate project. So basically, I've copied this into the pyRevit library, just for people to be able to have easy access to it. You can, if you don't want to use pyRevit, you can still download Revit Python wrapper and assign it, give it, set up the paths and stuff like that, and still use it within the Revit Python shell environment to do your scripts and stuff like this. Or you can use it within Dynamo if you need to. It's a super powerful and advanced piece of code for Revit API. So you don't then technically, if you're planning to use pyRevit, you don't technically need to install this. Just I wanted you to know about this because we're going to use this a lot. The documentation for this is very important. Make sure that you know that these two links are here. pyRevit documentation, which is sort of like progressing, and I'm adding more stuff to it. This is the one that talks about the pyRevit core and how it works, and what's the pyRevit loader and stuff like that. If you want to learn more about how really pyRevit works behind the scenes, and if you follow the other link, it takes you to the Revit Python wrapper documentation, which we'll get to it when we actually start writing scripts in Revit. So I talked about 4 different subjects for you today. The first one was the Python itself, Python language itself, and the differences between Python and IronPython. The whole purpose of this was to give you a sort of like a bird's eye view of how things work within this for Python programming for Revit Basic. So this is the Python organization website, as I showed you before. We talked about Revit Python shell also. Make sure you get that installed. It's super helpful. It's on the releases again. You can go here and download the most recent installer for it, and know about Revit Python wrapper. I'm going to use the GitHub again. This is Revit Python wrapper, the Git repository, and the link to its documentation is also provided here. And the last piece of this is basically the pyRevit itself, which I've explained in other videos how to install it and where to get it, and where to get the tutorials, and where to find the GitHub repository and stuff like that. So have these tools ready in hand. With all this said, we will jump into creating our first tool for Revit, and we're going to use pyRevit to basically add it there and have it as a button that we can easily use and share with other people.